Okay guys, we're going to talk about weather and climate today. I'm trying to get through this. I was hoping to find a better way to do this, but with the hurricane coming, I had to push through. So we're going to talk about weather and climate, things that cause weather and climate. First of all, what are they? Weather is at a specific time. So if I say on August 25th, it is a high of 92 degrees and sunny outside. That is weather. We're talking about a specific time. If I say in January of 2017, it was rainy. Well, that's still a specific time because we're talking about January of 2017. If I say usually in January, usually in January, it is rainy and in the 60s. That's your climate because that's the average. That's how it usually behaves. Climate, we're usually talking about a specific climate type. So I would say for Houston, it's humid subtropical. You're gonna need to know humid subtropical because that's what Houston is. And I will ask you over and over and over again, what is the climate type of Houston, of the woodlands? And you will tell me humid subtropical. So like on that 5 themes of geography that hopefully you did, one of the questions was the climate of the woodlands. A lot of you said hot and humid. That's great. The specific climate type though is humid subtropical. And we'll learn about what makes it humid subtropical in the next day or two. Hello, now it's not working. All right, weather results from a complex interaction of several things. So this is going to be important. This is what we call our lane cows, our reasons, or our things that affect the type of climate. So amount of solar energy received. That's saying how much sun you get, all right? So if you get more sun, you're going to be warmer. If you get less sun, it's going to be colder, all right? A lot of this is determined by your latitude, how close you are to the equator. Think about it. Everywhere on the equator, except for like one exception, but on the equator, you are sunny all year and it's warm, all right? Because you're right there, you always get the sun's rays. The closer you get to the poles, the colder it gets, okay? Amount of water vapor in the air. Think about humidity, all right? Think about how when it is hot and humid, that feels gross. It's hotter than when it is just hot and dry because that humidity in the air, it like exacerbates, it makes worse what the climate is, all right, what the temperature is. All right, cloud cover. This does 2 things. Cloud cover can give you shade and kind of keep you cooler in the day, but also at night, it traps in that heat. So think about the desert. The desert gets real hot during the day, okay, because you have all that sun. But then at night, there's nothing to trap that heat in. So all of that heat escapes. There's no cloud cover. Landforms and bodies of water. These act as barriers. Barriers to the air movement, barriers to a lot of things. Water bodies, this is gonna be big too because water helps moderate temperature, helps keep it in the middle. Elevation. The further you rise up, the colder it's going to get. Okay, the temperature at the base of a mountain versus at the top of the mountain is going to be different. No matter where you are, latitude-wise or anything else, okay, you lose about 3.5 degrees for every 1,000 feet you move. Doesn't sound like much, but it adds up. And then air movement. Okay, just like ocean currents, air moves around. We move hot, we move cold, goes all around the globe, and it moves that warmth and that cold around. All right, precipitation. So if it is wet, I always say if it's wet and it's falling from the sky, unless it's bird pee, okay, it's precipitation. Rain, sleet, snow, hail, splain, whatever you want to call it, right? There's 3 types, all right? Pre-AP needs, or honors, call it now, needs to know these 3 types, and then level does a little bit, but not as much, okay? The first type is convectional. We get this a lot. This is the type of rain, if you've ever been to Costa Rica or Panama and you're like, oh my gosh, it rained every day at 3 o'clock. That's convectional rain, all right? So what happens is you have that humidity in the air, you have that dew on the grass, the sun comes out, it heats all that up, or the ocean or whatever, heats all that up. It rises, cools, condenses, and then in the afternoons, these clouds have formed and you have precipitation, okay? That's convectional rain. The next, we're gonna see this diagram a whole lot. You're gonna need to know this diagram. You're gonna need to love this diagram. We're gonna talk about it today, and we're gonna talk about it in the next set of notes as well. This is what we call orographic precipitation. I know you can't see that because of the glare, but I'll write it down here. Orographic. Okay? And what this is, orographic, is very easily, it's what we call the rain shadow effect. Okay? So you have a mountain. So think about like Seattle, Washington's a good example. Okay? You have this mountain. All right? You have this warm ocean, or just this ocean, you have water. Okay? What does water do? Well, it evaporates. It goes up and it forms the cloud. When the cloud gets up, okay, all this water starts getting in the cloud. Okay, big cloud forms. All right. Well, that cloud is now stuck there. It's not smart. It doesn't have a brain. It doesn't know go around the mountain. It just is there, and it's going to continue to crash into the mountain. It's going to continue to crash into the mountain. Okay. So the big old cloud crashes into the mountain, and it's like this. It's like, I can't get by. I can't get by. Okay, well, as it just gets bigger and bigger and bigger, what ends up happening is, this is what I was looking for, because y'all can't really see the mountain. Okay, what ends up happening is it has to get rid of all of that precipitation on this side of the mountain. Okay, so on this side of your mountain is lush vegetation. Okay, so you get lots and lots of water, lots and lots of rainfall. That's your lush vegetation, okay? Well, by the time the cloud gets over the mountain, it's not very happy. There's nothing left of the cloud, okay? I'm sorry you can't see that, but there's nothing left of this cloud. So this side is arid, and arid means dry, okay? So this side is a desert. Only one S. Okay, but more importantly, it's what we call the rain shadow. All right, think about a shadow when you're a little kid on the playground. A shadow is the lack of sun, just like a rain shadow is the lack of rain. Okay, you wouldn't have a rain shadow where there is rain, just like you're not going to have a regular shadow where there is the sun. Okay, think about this cloud or this mountain. This mountain is like this big barrier right here saying, no, rain's not getting by. And so it casts a shadow on this side. So this side doesn't get any rain. This is your rain shadow. All right? All of that is orographic precipitation. Here in the woodlands in Houston, we do not get orographic precipitation. All right? Can you go get me the eraser over there? Okay? We get convectional, but we have no mountains to give us the rain shadow. Another example, my personal favorite, being from Colorado, is if you've ever flown into Denver and then you go skiing in the mountains, like a Copper or Breck or whatever. Okay, you go up and it's sunny on this side from Denver. Okay, and then you go through the Eisenhower Tunnel. It's the big tunnel that goes through the mountain. Okay, but over and over and over again. Okay, you go in this side, it's sunny. You come out this side and it's snowing. All right, because it's that same thing. All of this snow, all of these clouds are stuck on this side of the Continental Divide. They're pushing into these mountains and they're stuck. It's why most of your ski resorts are on the western slope, because it's like it causes a rain shadow, the orographic precipitation, all right? Not saying you don't get any precipitation, you still get precipitation on that side. You just don't get nearly as much. Okay, the last one is frontal precipitation. We get this a lot too, all right? This is, you've got warm air, it's sticking around. This is what we're gonna get a lot of here in September, October, all of that, because you've got this warm air, it's sticking around. Then all of a sudden, a cold air front comes in. Well, warm air, it's going to have lots of humidity in it. Well, as that warm air is pushed up, because remember, warm air rises, as that warm air rises, it takes that humidity with it. Okay, well, that humidity goes up, it cools, condenses, and we get rainfall. So whenever you hear, oh, a cold front is coming, that usually means that we're going to get precipitation from that. Okay, as that cold front comes in, it pushes the warm air up, and we get precipitation. Weather extremes. Oh my goodness, what do we have coming? Hurricane. Okay, whether it's a hurricane, a typhoon, a cyclone, these are the same thing. We just call them by different names depending on what ocean they are. And there's some gray area on that too. Okay, if it's going to Southeast Asia or East Asia, we call it a typhoon. All right, if it's going to be down here in the Indian Ocean, okay, it's a cyclone. All right, generally they say cyclones are below the equator and typhoons are above, but again, there's some gray area on that because a lot of times they'll call cyclones, they'll call it a cyclone over here too. So there's some gray area. We just call them hurricanes. If it's coming towards the US, it's a hurricane. Our hurricanes start off over here off the coast of Africa, come over, and they go up. They're going to go up two ways. They're either going to go up our east coast, which us in the Gulf Coast are a little more happy with when that happens, or they're going to come into the Gulf of Mexico and the Caribbean. All right, that's what Marco and Laura have done. Is they came into the Gulf. Tornado. Okay, powerful funnel-shaped column of spiraling air. I was unlucky enough to to witness three tornadoes this year? 3 tornadoes over the spring and in the summer, thanks to COVID. I happened to be in the very wrong place at the wrong time. And they come out of nowhere. You're sitting along, you're like, oh, that's a funnel cloud. That's a tornado, okay? Now, if you were in class, I'd say, which has more powerful winds, tornado or hurricane? And you would say, okay, you would say a tornado. A tornado has more powerful winds, okay? But a hurricane is going to be more destructive because a hurricane is this huge, giant force moving ever so slowly with lots of rain. Whereas a hurricane is like, I don't know if you ever watch like Looney Tunes, where it's like just this little Taz, where it's like, boom, boom, destroys as much of it as it can in a very short period of time. They're usually only on the ground for a few minutes. Yes, they can be on the ground for an hour or so, but that's not the usual case. Usually it's only a few minutes, and they can be a mile wide, but that's not usually how big they are. Whereas a hurricane can be as big as a state. Okay, not the whole thing, but it's just this massive thing, whereas a tornado is like fast damage, okay? But the winds of a tornado are stronger and faster. Okay, so we have the Fujita scale to measure them, and it's all about like, the stronger the winds, the higher on the scale it is. My personal favorite, blizzard. I love blizzards because you're like stuck inside. You can go outside and like play in the snow. You can like dig yourself a little alleyway through the snow, and gives you some good killer snowboarding. Drought. Y'all learned about the Dust Bowl in Texas history. Drought just means it's really dry. Okay. The opposite of a drought would be flooding. Well, we also get a lot from hurricanes and when there's a lot of rain. There's a lot of things that go into why we flood more now, which I'm not going to do, but it can. All right, Earth's position in relation to the sun is the most important factor in determining climate. What does that mean? Okay, what that means is the Earth, where it is pointing at the sun. Okay, so I need something to look like a sun. Okay, I don't have anything.
Mama.
What? You need a sun for me? Oh no, I meant like this. Okay, so let's say this is the sun. It's black sun. It's like a death sun. Okay, well this sun right here is pointing at
Right now, it's pointing at the southern equator, or the south of the equator, okay? So you'll be able to figure out
which one is, you know what I want? We're gonna use this, sorry. I'm definitely not a Boy Scout because I'm not prepared. Okay, this is the sun, okay? That's the sun. So right now, you have the sun and here's the equator. Okay, so to determine what season it is, you find the equator, all right, and you look at the axes. Okay, so here's this axis, here's the south axis. One of them is going to be pointed more towards the sun. Okay, so right now, the southern axis is closer to the sun than the northern axis. All right, so this sun's rays is pointed at the southern hemisphere. All right, that means that the southern hemisphere is having summer. All right, the axis, the tilt on the axis is what gives us our seasons. The axis, the imaginary line through the center of the earth, north and south poles, whatever. But what that does is it gives us our seasons. All right, so if you are pointed towards the sun, then you're having summer. If you're pointed away from the sun, then you're having winter. All right, so here's what you think about that. Think about like our seasons right now. All right, we are in summer. All right, fall technically starts September 23rd-ish. Right now we're ending our summer. In Australia, this is South America, but in Australia, which is over there somewhere, they are ending their winter. All right, so when we have summer, they have winter. When they have summer, we have winter. And the seasons are always going to go in the same order. Winter, spring, summer, fall, oh, I love them all, or whatever the rhyme is. All right, so when we have spring, they have fall. As we are about to go into fall in September, everybody in the southern hemisphere is about to go into spring. So whatever we are, they are the opposite. This is this Earth-Sun rotation thing that you may or may not have seen on the calendar of assignments. It's what you're going to be doing in next class. Okay, so you'll probably want to come back to this to help you figure this all out. Okay, but this is what gives us our seasons. This is the most important thing in determining your climate, because if you are right here between the tropics, no matter which season it is, that sun is giving you direct rays, because the sun never, ever, ever goes below the Tropic of Capricorn, and it never, ever, ever goes above the Tropic of Cancer. Get out here. Okay, so Cancer's in the north, Capricorn's in the bottom. I always remember it because Cancer would come in alphabetical order before Capricorn. And it's shorter, so it's on top, and Capricorn's heavier, so it's on bottom. Remember it how you will. Doesn't matter. As long as you remember that the sun is never going to leave this. So this is why that's so warm. These areas between the tropics are going to stay warm. Okay, revolution. Okay, a revolution is it. Think about the saying, the earth doesn't revolve around you. You don't say the earth doesn't rotate around you, because that doesn't make any sense. You say revolve, because to revolve means it goes around, right? So you have the earth and it revolves around the sun. I am the sun, the earth revolves around me, okay? But as it does so, that's a rotation. So every 24 hours, it is rotating. Every 365 days, it is revolving, all right? So that's also going to help give us our seasons, is this revolution as it like revolves, and then the whole tilt and all that. Okay, do you see this chart? This chart, you will know, you will love, you will have it on your test, you will have it on your quizzes, you will have it on the worksheet you have to do tomorrow, all right? It's really simple to read if you just sit there and you look at it. Don't rush it. When people look at it, they're like, I don't know what to do. Obviously, the sun, okay? It's showing the 4 seasons, okay? So you have the vernal equinox, which means spring. The autumn equinox, this is talking about the northern hemisphere, okay? An equinox is one of 2 days about March 21st, September 23rd, which we're getting closer, where the sun is directly over the equator. Okay, so you have the equator, or you have the globe with the equator, and then we'll just put the sun over here so it's out of the way. Okay, so the sun is shining directly at the equator. That's the equinox. Okay, because equinox is equal. The days are equal in day and night. 12 hours in the morning, 12 hours at night. If you were on that equator, you would have exactly 12 of each. We're not on the equator, so we don't have exactly 12 of each, but we're close-ish. Okay, that's what the equinox is. Okay, because they are equal. All right, then you have the solstices. This is the longest and the shortest day of the year, depending on where you are. Okay, so here's how you read this chart. All right, so you have the sun, you have the earth, you have the earth, earth, earth. Okay, well, you know the top and the bottom are equinoxes because the sun that you can't really see on here is pointed directly at the equator. Okay, so you know those are equinoxes, and that's going to be always true. It's always going to be equinoxes on the top and the bottom. But what you have to do is you have to look at these globes and figure out which one is having summer in the north and winter in the bottom, and then winter on top and summer in the south. Okay, the way you do that is you look for the axis. Okay, you look for the axis and you look for the sun. So here's the axis here, here's your equator, and then the dashed lines are the tropics. Okay, so here, okay, there's two ways you can tell. I might have to help you zoom in. Okay, we're going to zoom in for you. Okay, so here, all right, you have your globe and you have your earth. Okay, this axis, sorry to brain fart for a second, this axis is pointing towards the sun. This axis is pointing away. Okay, so if you're pointing away, you're colder. If you're pointing toward, you're warmer. All right, the other thing is this arrow, the sun's rays, let me make it a little clearer, okay, is pointing at the Tropic of Cancer. It's on top, okay? So that means they're getting more sun. If they're getting more sun, then they have to be summer up here, and then winter down here, all right? I'm hoping this isn't going to be backwards. So summer and winter, which means on the opposite side, it's going to be the very same thing. So you find your axes, okay? I sound like a math teacher. Find your axis, okay? This one is pointed away, and that one's pointed towards. So if this one's away, it's got to be winter in the north and summer in the south, okay? And then you're still not sure, okay? You just find that sun's rays, okay? Where's the direct sun rays pointing? It's pointing at the Tropic of Capricorn, okay? So that means the south. And then, because, you know, you've been in school your whole life, you already know the order of the seasons. So if you know one season, then you know them all right? So if you know that you have summer up here, what season always comes after summer? Fall. So if it's summer in the north here, and we're revolving this way, thoughts not a good mark anymore. Oh, made it. Y'all couldn't see that, but I promise you, I made it. Okay. Okay, so we're revolving this. Ooh, that's a good one. All right, so that means up here is fall, and that means in the south, it's spring. Because remember, again, they're always opposite. Okay, so we determined that this one was winter, and down here was summer. Okay, so after winter, always, 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 because you can't go winter and then fall, up here in the northern hemisphere is spring, or vernal equinox, and down here is fall or autumn, right? That's how you read this chart. All right, so you have the beginning of each one of the seasons. You just look for the sun, look for the axes.
Sorry, that would be my son that y'all hear laughing. Surely he's laughing at me. Okay, Tropic of Cancer, okay, and Capricorn, the furthest north and the furthest south the sun will ever go. Okay, it's not going to go further north or south. All right, so, but what that means is that this area between here is always going to be warmer. This is what we call the tropics, or the low latitudes. We call it the low latitudes because they are low in number, because obviously you have 0 in the middle, and then sorry, I'm trying to position this a little better. Yeah. Okay, midnight sun. This is not something totally important right now, but we're gonna go over it. Okay, so this is the area, so here's your chart again. Well, this is, if you've ever heard about Alaska, how in Alaska during the summer the sun never sets, or in the winter it doesn't ever get light. Well, what's happening is that this right here, so this is pointed away from the sun, so this is winter, okay, and this is pointed towards the sun, so this is summer. All right, well, so here's your Earth's rays. So because the Earth's sun rays is going all the way over the poles, since that pointed away, it can be in the middle of summer in the southern hemisphere, and they're still getting light. Up here in the winter, all right, so it's December, and it can be 1 o'clock in the morning. That's confusing, but that's there. Or it can be 1 o'clock in the afternoon, and you're still not getting sunlight because the sun's rays can only go so far. It's only getting half of the Earth, okay? And then here's your tropics and your equator, tropics, okay? It's still shining directly. The direct rays is still right there, okay? But because the Earth is tilted, it's pointed that top away, so it gets a little lighter, but not so much. So this would be in the summer, okay? This would be like Alaska in the summer at 1 a.m. It's still light, I say. So why people get real depressed up there in the winter, because they never see the sun. Ding, 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 ding. Greenhouse effect. Sun goes in, it's trapped by the gases, blah, 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 and it's trapped in there and it can't get out. Okay, I think, this is pretty long, so I'm going to stop this for today, and then, or we'll stop this one for now anyway, it's pretty long, so.